So thanks everyone for coming, both remote and in person. As Ron mentioned, this is going to be a recap of a lot of the reInvent announcements that happened last week. We're not going to cover everything, and we're not going to go to like the 200 to 300 level depth. We're just going to introduce kind of what the announcements were, the key takeaways, and if there's questions about them, or if we want to have kind of sidebar conversations, we can certainly do that. So the intention is to kind of throw a lot at you, run through a ton of different announcements, and very quickly get through all of the areas of infrastructure services, security, Gen AI, and analytics. So just a quick introduction. My name is Nick McCabe. I'm a solution architect here at AWS. I've been with AWS for 5 years now, and I'm a part of our games team supporting specifically betting and gaming customers. So think, the large online mobile sports books, or large online iCasinos, as well as physical brick and mortar casinos. So I'm going to be covering the infrastructure services, primarily compute, containers, storage, and network. And then I'll hand it over to the next presenter to get into some additional topics. All right, so Ron did a good job introducing what AWS reInvent is. For those of you who don't know, this was the 13th reInvent conference, with the first one being held in 2012 with 6,000 employees. You can see this year we had 60,000 plus employees, attendees. So I can actually speak to it. I went to some of the first reInvents. It used to be very small, just contained at the Venetian, very manageable. Now it spans the entire strip, and if you've been there, it's kind of tough to get around if you've ever navigated Vegas, but it's a very, very large event at this point. So like I said, approximately 60,000 employees. We had about 1,900 sessions delivered by over 3,500 speakers, which include AWS solution architects and experts, as well as customers and partners. From an announcement perspective, overall, we had 546 announcements. Those announcements could be brand new services, they could be features, and we had, you'll hear kind of throughout the presentation, pre-reInvent and then at reInvent. So we had 422 announcements that were pre-reInvent, and then 124 announcements that happened at reInvent. And so what we've done is we basically, across all of those announcements, we've tried to distill down kind of some of the more important things to share with everyone today. All right, so we're going to start off with compute, and if folks have questions, feel free to ask. A lot of these services are new, so part of my role, Bert's role, John's role is to start to learn some of these things, and we're kind of learning with our customers. They don't give us a ton of foresight into what's going to be announced. So that's the challenge, and a part of the job is to start to learn these things as they get announced. But please feel free to ask questions. So like every year, in 2024, we have a new set of announcements for existing EC2 instance families. This year was focused primarily on storage optimized. You'll see them on the slide there as the I series, and GPU powered instances. You'll see them there as the P series. And really the name of the game with any of our new instances in most of our families is to get Graviton 4 into those instance families. That's our new Graviton processor. And then also the name of the game here, if you're on an older instance type, the newer instance types, you get better price performance. So you get more CPU memory, the latest CPU memory at a cheaper cost. So the next service I wanted to make you aware of was our Amazon Elastic VMware service. This is a preview service, and it's really for customers that are looking to get out of a data center very quickly, and maybe they don't have the time to upskill their people on what cloud is. So what EVS is intended to do is to accelerate migrations. Like, let's say you have a data center contract coming up on renewal. You could use EVS to relocate your servers to AWS, and still use the same VMware tooling, vCenter, all those types of toolings that you're familiar with, from an on-prem perspective. So you can see here on the slide, right, we have all these different types of ways you can migrate to AWS, with at the very top being refactor, which takes a lot of time and effort. all the way down to the bottom, you can view this EVS service as a way to just simply relocate with very little effort. Future dated capacity reservations. So most folks are probably familiar with reserved instances and savings plans, which are cost savings vehicles. If you're not familiar with what capacity reservations are, they're a way for you to guarantee capacity in a given availability zone region, for things like a Black Friday, for things like DR where you can never go down. In the past, you would have to make those reservations, capacity reservations, at time of deployment, and in often cases, or some cases, the capacity might not be available for you, just given the demand for those instance types and instances. So what future data capacity reservations allows for is it allows you to schedule your reservations up to 120 days out, in advance of your event. Essentially, and you don't pay for it until you start consuming it, right? So if I schedule a capacity reservation for 120 days out, I'm not going to start paying for that capacity reservation for 120 days. So this is powerful for folks using maybe some of the more in-demand instance types that are tough to get their hands on. All right, the next couple slides, I want to just kind of briefly talk about the innovation that we're doing across our entire compute stack. If you're very interested in hardware, how AWS data centers work, kind of what we're doing to the compute stack as it pertains to generative AI and machine learning and how we're building supercomputers, I definitely suggest taking a look at the keynote with Peter DeSantis. It's a really cool talk. He even brings the rack right up on stage. These next kind of few slides, they're going to touch on some services that maybe most customers aren't going to use as a primary end user, but will all benefit from kind of upstream. So if you're using generative AI or building generative AI applications, a lot of the things we're going to talk about here, you won't use directly, but you'll benefit from indirectly. So last year at re:Invent, we announced our Trainium 2 processors, and we shared our plans for enabling the next generation of model training and inference. This year, we brought that vision to life with our Trainium 2 servers. So Trainium 2 servers, they are really for training large language models, and they provide 30 to 40% better price performance over the current EC2 GPUs. So for those that are building large language models, this is going to be the future, and where we foresee many of the large model providers doing a lot of their training. Really quick, so Neuralink is worth pointing out. If you saw on my last slide, you can see there Peter DeSantis is standing in front of one of the EC2 Trainium, or sorry, one of the Trainium instances. So that rack right behind him is one rack, or one server, one Trainium 2 server, and as that server, because of that server is very large and it's disparate, we need networking to be able to connect the Trainium 2 chips that are part of it. So Neuralink is a technology that we use to essentially enable that chip-to-chip connectivity, both on a Trainium server, but then also, let's say you can't get enough computing power out of one Trainium server. We use Neuralink to be able to stitch together multiple Trainium servers into what we refer to as an Ultra server. So at re:Invent, we announced in preview a Trainium 2 Ultra server, which is it's 2 racks. You can see it there on the slide. Peter DeSantis brought up a rack on the stage. It's 2 racks, and it's 4 Trainium 2 servers all stitched together using that Neuralink capability. So a lot of the model providers, as I mentioned, they'll likely use this, like Anthropic. They will use this to train their models in the future. And while most of the AWS customers won't directly use this service, we'll all benefit from the models that get output as an output of this. All right, any questions about compute? Yeah. All right, we're going to hop into containers. So this year for containers, for those of you who aren't familiar, Amazon EKS is our elastic Kubernetes service, which allows you to run Kubernetes clusters within cloud. In the past, with EKS, you would have to manage the underlying infrastructure, meaning the operating system, the servers. How do you scale those? How do you patch them? How do you monitor them? With Amazon EKS Auto Mode, AWS takes over all of that undifferentiated heavy lifting and allows you to focus essentially more on managing your actual applications and lets AWS handle the underlying operating system, patching, monitoring. So you can see here on the slide, essentially what we did was we shrunk the amount of responsibility on our customers, and AWS is taking over management of some of the more underlying, I'll call it infrastructure type work. EKS hybrid nodes. So if you're familiar with kind of the methods and models that you can run EKS, we have a number of them. You can run EKS in the cloud in any AWS region, which is we refer to as Amazon EKS. And then we have our cloud disconnected on the other side of the slide for environments that need to be firewalled off, where you can run EKS anywhere. In the middle there, we had in the past, if you had to run infrastructure on-premise, you could use Amazon EKS on Outpost, but we didn't really have a solution for customers that didn't want to purchase an Outpost or have existing hardware. And what Amazon EKS Hybrid Nodes does is it enables customers to leverage a single control plane that runs in the AWS region in the same AWS console as your cloud-based EKS clusters, and basically manage your own EKS clusters on your own provisioned hardware. So again, it's really kind of the idea of whether you're using EKS within a region, EKS on an outpost, or EKS on your own hardware, bringing that management experience back to a single control plane. All right, the next announcement was enhanced observability for ECS container insights. This was something that we announced last year for EKS, and all of our ECS customers got excited and started asking, why can't we have this for ECS? So what this allows you to do is to essentially observe or get insight into service and task level data that you can correlate with cluster level data. So again, for ECS customers, more monitoring, more observability, more insights into the health of your clusters. All right, the last container related announcement I wanted to bring up was ECS predictive scaling. So if you're familiar with auto scaling, especially for ECS, it's typically a reactive scaling. So you would typically set thresholds. They could be CPU, they could be memory, it could be some sort of an application metric. But as your application comes to that metric, you would then scale out. What predictive scaling is intended to do is to set essentially predict when to scale and do it in advance. So if you have I'll call it a very cyclical or a regular kind of, if you have like a regular traffic pattern that happens either daily or monthly, what you can do is set predictive scaling policies. And as ECS learns your application traffic, it will get better and it will scale ahead of those. One important thing to note, you can set these policies as forecast. So when you're initially testing this, I would set it up in forecast mode, which means it will just simply show you what it would have done from a scaling perspective based on your traffic. And then once you're comfortable enough with it and you feel the scaling, predictive scaling knows your application well enough, you can then actually have it scale on demand. Any questions about the container announcements? All right, we'll hop to storage, migration, and transfer. Bert, how am I doing on time? Do I need to speed up?
10 more minutes.
All right. All right. So S3 got a lot of love this reInvent. I'll call this a top 10 announcement. If you're looking for how to efficiently handle analytic workloads in Amazon S3, this announcement is for you. At reInvent, we announced a new bucket type called Amazon S3 Tables that's integrated with all of our AWS analytics services like Athena, Redshift, EMR, and it's discoverable in the AWS Glue data catalog via lake formation. In terms of performance, S3 tables have the order of magnitude of 3 times, order of magnitude of speed of 3 times, and throughput 10 times compared to self-managed tables. And so a table bucket, it's a regional bucket. It acts as an analytics warehouse that stores Apache Iceberg tables in Apache Parquet format with various schemas. Additionally, as customers are accustomed to with S3, you get all the same durability, availability, scalability, and performance of S3. So again, this is one of the big ones. If folks are out there using Apache Iceberg and are familiar with Apache Iceberg, this is AWS's capability to enable some of those workloads. Amazon S3 metadata. This was another large announcement of ours. If you're familiar with managing S3 metadata today, it can kind of be a bit of a mess, and it's a very self-managed process, and it could be very labor intensive. And so what we announced here was essentially an automatic or very fast way to instantly discover information about your S3 data to be able to more easily search it. Any questions about either of those two? Great. Storage browser for S3. So if you have web applications and you're a developer and you want to embed an Amazon S3 interface into your application, this is a customizable way and a user-friendly way to embed S3 and S3 objects and buckets into that front end with an AWS Amplify React framework. So again, in the past, you would have had to have done all of this kind of by yourself and self-manage it. We're offering a more easier or a simplified way to interface with your data that's stored in S3 for front-end web applications. Now, if you don't want to build your own web app and embed S3 into that web app, we have AWS Transfer Family for web apps. A perfect example of this is I have a customer in the gaming space that the way they essentially provide casino games to their casino customers who are, quite frankly, they're not technical, is they had to provide some sort of short-lived credential to log into the console and pull down the games, right? They've been asking us for a capability for years to basically put a front end on S3 that they could have their customers or some sort of portal in front of S3 that they could have their users log into to pull down those files. So with AWS Transfer Family web apps, you're able to do that. With a couple clicks, you can get a front-end web app created. You could provide credentials to your end users, and they could log into S3, download, upload, and copy files as needed. So this is a pretty interesting one for folks who need to share files with customers. S3 new default data integrity. So for customers that have strong integrity checking requirements, previously you could specify an alternate checksum algorithm and provide your own pre-computed checksum into the upload to S3. However, this required some configuring of tools and management on the customer side to generate and track checksums, which leads to complexity and really, again, a lot of, you're getting a theme here, right? A lot of undue heavy lifting on the customer. Now with S3 SDKs, you can automatically calculate CRC-based checksum for each upload and send it to S3 for integrity verification. Intelligent tiering for Amazon FSx, OpenZFS. So this is an interesting one. If you're familiar with intelligent tiering for S3, essentially what this will allow you to do is to save cost on your Amazon FSx storage by moving your files to the most cost optimized storage class based on the access patterns. So for unfrequently accessed files, it'll move it to the cheaper storage tier. For frequently accessed files, it'll move it to the hotter tier. And we're seeing customers have up to 85% cost savings. So if you're familiar with intelligent tiering for Amazon S3, very similar capability that we're bringing to FSx, which should help customers save money. Right now, it's for OpenZFS. I'd hope that we're starting to look at this for other FSx flavors as well. There wasn't a whole lot of announcements for EBS, but this was one. I just wanted to give EBS some love here. In the past, if you had scheduled a snapshot, there was no guarantee that it would complete within a given time frame. With time-based snapshot copy for Amazon EBS, you can now specify a desired completion duration, and this is important for things like DR, compliance, hitting some RTOs and RPOs as it pertains to your DR strategy. So what you basically do in the console when you schedule a snapshot is you can specify a desired completion duration. That can be anywhere from 15 minutes to 48 hours, depending on how large the snapshot is. I'm getting the 5 minutes. Last storage update that I wanted to provide. This is kind of an interesting and cool one. I've heard this from my customers before who kind of don't trust the snowball back and forth process where Amazon ships them a snowball, they upload their data to the snowball, and then it ships back via third party. What we announced at reInvent was we now have data transfer locations and terminals. Right now, those locations are in Santa Clara, California, El Segundo, California, and Seattle, Washington. I'd imagine we're going to add more. There's a blog post on this, but essentially what you do is you can bring either any third-party device, storage device, or an AWS Snowball or Snow Cone to those locations, and you can plug right into the AWS network and upload your stuff to AWS. So pretty interesting. They even have pictures of Jeff Barr going through the process in that blog post that I mentioned. Networking and content delivery. So this is an interesting one. You can now access VPC resources via private link. So if you remember in the past, the way private link worked was you essentially establish a private link connection to either another VPC or maybe a SaaS provider. And there was the need for a network load balancer on the other side of it that you would target. You can now target specific resources on the other side of that and really get rid of the need for that network load balancer. So while maybe a minor change here, it's definitely makes life a little bit easier. You don't have to manage or pay for a network load balancer anymore with private link. Cross-region private link with interface endpoints. So this one is interesting. If you are using, let's say, AWS in US East 1, and you're using a SaaS provider that was located in US West 2, what you used to have to do in the past was create network connectivity and network connectivity to that secondary region. It could have been a transit gateway and then a VPC in the secondary region, and you'd have to create that private link connection there. Now with cross-region private link, you can no longer need that secondary. You don't need to set up that network shell secondary VPC. You can just create the private link connection in your home region and access services that are in a secondary region. So again, simplifies your overall network architecture. You don't have to set up multiple transit gateways, VPCs, and in other bespoke regions that you don't want to operate in. All right, I went through a lot. Any questions?